Across Africa, the Middle East, and the global south, modern cities are overheating. Concrete towers trap heat, power grids struggle. Air conditioners run nonstop. Energy costs rise. But centuries ago, long before electricity, African builders already solved this problem. They didn't use steel. They didn't use cement. They used earth. And their buildings still outperform modern concrete in extreme heat. Today, we expose why modern architecture fails hot climates, and how African earth architecture got it right. Concrete dominates modern construction. But concrete has a serious weakness. It absorbs heat aggressively during the day, then releases it slowly at night. This creates what scientists call thermal lag. Buildings remain hot even after sunset. In hot regions, this leads to higher indoor temperatures, increased AC dependency, rising electricity demand, urban heat island effects. Entire cities become heat traps. Concrete was designed for industrial speed, not climate adaptation. Across the Sahel, Mali, Niger, Burkina Faso, Sudan, African societies developed earth-based architecture perfectly adapted to heat. These buildings use thick mud brick walls, natural ventilation channels, courtyards, and shaded interiors, local earth materials. The science is simple but powerful. Mud walls absorb heat slowly. They store it, then release it gradually overnight. This keeps interiors cool during peak daytime heat. No electricity required, no machines, just physics and environmental knowledge. Often dismissed as primitive, the Great Mosque of Djenné is actually a climate-engineered structure. Its features include thick thermal mass walls, elevated structure for airflow, wooden Toran beams for structural support and maintenance, breathable materials that regulate humidity. For centuries, it has survived extreme heat, dust storms, and seasonal flooding, not by accident, but by intelligent environmental design. When colonial powers imposed European architecture on Africa, Asia, and the tropics, they ignored local climate science. Glass windows, thin concrete walls, steel roofs. Buildings designed for cold climates were placed in deserts and tropical zones. The result, overheating, energy dependency, structural inefficiency. Traditional African builders understood climate adaptation. Colonial planners prioritized uniformity, not survival. Today, architects are rediscovering what African builders mastered centuries ago. Earth architecture is now used in eco-housing projects, climate-resilient schools, low-energy urban design, sustainable housing initiatives. Why? Because it is low-carbon, locally sourced, thermally efficient, cost-effective. Modern science is confirming ancient African engineering. As climate change intensifies heat waves, cities must adapt. The future is not more concrete. It's smarter materials, climate-responsive design, and learning from indigenous engineering. African earth architecture isn't history, it's a blueprint. For centuries, African builders solved heat without machines. Now the modern world is finally catching up. The question is no longer whether earth architecture works. The question is, will cities listen? If you want more untold African science, engineering, and history, subscribe and turn on notifications, and comment below. Should modern cities replace concrete with climate-smarter architecture?